Hello, this is Jay Coder back with another stream. We're going to be continuing on the code lab that we were working on yesterday. So, if you have not seen that video from yesterday, please go ahead and take a look at that because we did that part first. And so, we're going to be continuing on the second part, and I'm just gonna go ahead and get started since this is a continuation. And so, also, I'm gonna post in the chat the link to the code lab that we're working on right now. So, let me go ahead and post that really quick. And alright, I posted that in the chat. And so, we're continuing on going over the code lab classes and inheritance in Kotlin. And so far, this is what our code looks like in this box right here. And actually, let me go ahead and mute the music really quick for you guys. Okay. All right. All right. There's just a little delay on muting the music, but oh well. Let's go ahead. And so the code lab is we have this code so far inside our Kotlin playground. So we're going over classes and inheritance, and we have a dwelling parent superclass, and then we have a child called Square Cabin, and the child has these attributes: the build, material, and wood, and inherits, and which is set to wood, and inherits these attributes, which dwelling also has a building material and a capacity. And we set these variables here, and then we pass in the residence, and then so basically when we pass in the residence, it's getting it will set the parents one to the amount of residence, and then there's a method that checks if the space has room. If the residents are less than capacity, then there's no more room. And then we have these outputs here with this with statement that basically outputs these different attributes such as capacity, material, house room, and we pass in the square cabin. And so when we pass in the square cabin, we don't have to use the dot notation right here where we don't have to say square cabin dot capacity, because we use a with statement, and the with statement already knows what variable we're checking. So we save that little bit of code with this syntax if you guys are new to this kind of syntax. All right, so great. Let's see what it wants us to do next. So here it wants us to go ahead and create a round hut subclass, and the name in the same way the square cabin as the square cabin. Add another subclass round hut to the dwelling, override building material, and give it a value of straw, and override capacity and set it to 4. So we're gonna make another class here, and it's going to be, instead of a square cabin, it's going to be a round hut. So this is our round hut class here, and In main, create an instance of round hut with 3 residents. So we're gonna declare a an instance of round hut inside our main. Alright. So we have an instance of a square cabin and an instance of a round hut. Add the following code below to print information about the round hut. So we're going to do kind of the same similar thing that we did with the square cabin. So under this, we're going to print the details from the actual round hut that we declared right here. And it's going to, display the material and all of that. And so let's go ahead and run the run the code here. So when we run the code, it will now should print the details from both. So it's printing those details from square cabin and round hut. Material straw, capacity 4, has room true, because the amount of people passed in is only 3. So you now have a class hierarchy that looks like this, with dwelling as the root class and square cabin and round hut as subclasses of dwelling. Create a round tower subclass. The final class in this class hierarchy is a round tower. You can think of a round tower as a round hut made of stone with multiple stories. So you can make round tower a subclass of round hut. Create a round tower class that is a subclass of round hut. Add, add the residence perimeter to the constructor of round tower, and then pass that perimeter to the constructor of round hut the round hut superclass. Override building material to be stone. Set the capacity to 4. So now what it wants us to do is it wants us to go ahead and go ahead and also make a new class called round tower. And this round tower is going to inherit from round hut. This colon is used to inherit a class from round hut. So, alright. So this is going to be, this made of stone with a capacity of 4 as of now. Then what does it tell us to do? It says run the code and you get an error. So it already wants us to run the code. So let me see. So it gives us trouble inheriting it the way that we have it now. So when I hit play, it says this type is final. So it cannot be inherited from. So it's saying it's final and it cannot be inherited from. So let's see what's going on here. This error means that round hut class cannot be subclass or inherited from by default. In Kotlin, classes are final. So remember, in Kotlin, classes are final by default and cannot be subclassed unless it's abstract. You are only allowed to inherit from abstract classes or classes that are marked with the open keyword. Hence, you need to mark the round hut class with the open keyword and allow it to be inherited from. Note, you do not need to use the open keyword when defining abstract classes. Example, dwelling class does not need to be marked with open keyword. It is assumed that you will want to subclass an abstract class in order to implement the abstract properties and functions. Add the open keyword at the start of the round hut declaration. So we're going to add this open keyword at the start of the round hut declaration. And so it's going to be open class tower. In main, create an instance of the round tower and print the information about it. So we're going to go ahead and create this guy as well in our main function. We're going to make an instance of our round tower, and it's going to be called a round tower. And then we're going to go ahead and print the information much like we did before with the previous classes, where we're using a with statement to say, hey, we have this variable that is an object, and we want to display some of its attributes, and we don't want to have to write out the round tower dot whatever. So we can just go ahead and display the attributes without writing out round tower dot every time we want to display something. So that's what we have there. And then so we're going to go ahead and play that. And all right, so this type is file, so it cannot be inherited from. Oh, I'm sorry. The class that we're inheriting from needs to be open, not the class that we are trying to inherit, or not the child, but the parent needs to have the open class so that it can say, hey, I can have children, really, because well, yeah, pretty much this means, hey, yeah, I can have children. But if you delete that, by default, it's saying, by default, I cannot have children. So when you put open, then you say, hey, this class can have children. Also, abstract classes can have children as well. So when we play that, we see our round tower and the information there. Perfect. And that's what we have. And run your code, and it should now work without errors and produce the following output. So yeah, it produced that for us. It says add multiple floors to round tower. Round hut, by implication, is a single-story building. Towers usually have multiple floors. Thinking of the capacity, the more floors the tower has, the more capacity it should have. You can modify round tower to have multiple floors and adjust its capacity based on the number of floors. 1. Update the round tower constructor to take an additional integer parameter val floors for the number of floors. Put it after resonance. Notice that you don't need to pass this to the parent round hut constructor because floors is defined here in round tower, and round hut has no floors. So since we have floors, we're going to add a variable that's unique to round tower. So floors is unique to round tower. So we're going to go ahead and add that as well here. And let me see here. So set says val floors int. That's interesting. They decided to use the val there and not there. But anyway, val means that it will not be changed. Var means it it could be changed in the future, the number of floors. But logically, buildings usually do not change in the number of floors unless they're being renovated, remodeled. I mean. All right, so we added that, and now what does it want us to do? When, what? Okay, so okay, when you have multiple parameters and your class or function definition gets too long to comfortably fit on one line, you can break it up into multiple lines as shown in the code above. Run your code. There is an error when creating round tower in the main method because you are not supplying a number of floors in the argument. You could add the missing argument. Alternatively, in the class definition of round tower, you can add a default value of floors as shown below. Then, when no value for floors is passed into the constructor, the default value can be used to create the object instance. In your code, add equals 2 after the declaration of floors to assign it a default value of 2. So it wants us to give this a default value so that it can give the option of it not being initialized in when you instantiate it. So basically, they want us to give it a default value. A default value of 2. Let's see. Like when you don't have that and you don't add it, when it's instantiated here, then when you play, it will give you a no variable no variable pass for perimeter floors error. However, so we do want to, give it a default value. When we give it a default value, then boom, no error. All right, so we give it a default value and then run your code. It should compile because round tower 4 now creates a round tower object instance with the default value of 2 floors. In the round tower class, update the capacity to multiply it by the number of floors. So override val capacity 4 times floors. Run the code and notice the round tower capacity is now 8 for 2 floors. Okay, so we're going to go ahead and add this. Update the capacity. And instead of that, we want 2 times the capacity by the number of floors. Alright. And then run your code and notice that the tower capacity is now 8 for 2 floors. So that's pretty cool. That tower has quite a bit of room. So 2 floors, you can fit 8 people in that tower. And so here is your finished code. Alright. So modify classes in the hierarchy. Calculate the floor area. In this exercise, you will learn how you can declare an abstract function in an abstract class and then implement its functionality in the subclasses. All dwellings have floor area. However, depending on the shape of the dwelling, it's calculated differently. Define floor area in dwelling class. First, add an abstract floor area function to the dwelling class. Return a double. Double is a data type like string and int. It is used for floating point numbers that have a decimal point followed by a fractional part such as 5.8793. Abstract function floor area double. All abstract methods defined in an abstract class must be implemented in any of its subclasses before you can run your code. You need to implement floor area in the subclass. So they want us to go ahead and add this here, add this to our parent class, which is abstract. And then when you add abstract, you don't need to declare an implementation here, or you don't have to have an implementation here. This is up to the children to implement. So all abstract methods defined in the abstract class must be implemented in any of its subclasses before you can run your code. You need to implement floor area in the subclasses. Implement floor area for square cabin. Like with building material and capacity, since you're implementing an abstract function that's defined in the parent class, you need to use the override keyword. In the square cabin class, start with the keyword override, followed by the actual implementation of the floor area function as shown below. Return the calculated floor area. The area of the rectangle or square is the length of its side multiplied by the length of the other side. The body function will return length times length. So in the square cabin class, start with keyword override. Okay, so we're going to go ahead and put this in our, well, actually, it wants us to return the length times length. We're going to go ahead and put this inside our square cabin class. Actually, you know what? Just to demonstrate that error it was talking about, I'm going to hit the play button there. And then class square cabin is not abstract and does not implement abstract base. Class round hut is not abstract and does not implement abstract base. Class round tower is not abstract and does not implement abstract base. So all of those will need to implement abstract base. So for the square cabin, it wants us to have this code as our override. So the floor area is going to be length times length. And so, to calculate the area for a circle is different than calculating the area for a square. So the thing is, we are going to probably, have a different implementation for our round one. So the length is not a variable in the class and it's different from every instance. So you can add it as a constructor parameter for the square class. So they want us to add the length to be passed in as a constructor parameter for our square cabin. So the length is passed in to satisfy this. Length times length. And then dwelling, and therefore all its subclasses have residence as a constructor argument. Because it's the first argument in the dwelling constructor, it is best practice to also make it the first argument in all subclass constructors and put the argument in the same order in all the class definitions. Hence, insert the new length parameter after the residence parameter. In main, update the creation of the square cabin instance pass in 50 to the square cabin constructor as the length. So we're going to go ahead and also pass in 50 for the square cabin here in our main where we have it. So our square cabin, we're going to pass in 50, which is going to be our length, which our second variable right here is the length. Length is double, so it's going to have the floating point, which is the dot O. Inside the with statement for square cabin, add the print statement for the floor area. So for the floor area, we're going to add this inside the print statement for the square cabin as well. So we're going to add that there. All right. So your code won't run, and I know why, because we haven't implemented those other ones yet. Because you also have to implement floor area in round hut. Implement floor area for a round hut. In the same way, implement the floor area for round hut. Round hut is also a direct subclass of dwelling, so you need to use the override keyword. The floor area of circular dwelling is pi times radius times radius. Pi is a mathematical value. It is determined in a math library. A library is a predefined collection of functions and values defined outside a program that program can use. In order to use a library function or value, you need to tell the compiler that you are going to use it. You do this by importing the function or value into your program. To use pi in your program, you need to import kotlin.math.py. Import pi from the Kotlin math library, but put this at the top of the file before the main. So great, we're gonna be importing a library that we can use here, and we're going to be putting it at the top of main here, and then it says implement the floor area function for a round hut. So this is going to be what we're going to implement for round hut. So inside the round hut, we're going to go ahead and add this. So pi times radius times radius. And then warning, if you do not import kotlin.math.py pi, you will get an error. So import this library before using it. Alternatively, you can write out the fully qualified version of pi as in kotlin.math.py times radius, and then the import statement is not needed. Update the round hut constructor to pass the radius. In main, update the initialization of round hut by passing a radius of 10 on the round hut constructor. So in the round hut, we will need to pass in the radius because that's not going to be the same as the length, but it will be also passed in the same way as the length. So in the round hut, it wants us to pass in something which is 10.0. So we're gonna pass in 10.0 for our radius inside our round hut function, and then add a print statement inside the with statement for the round hut. So now we want to display the floor area for the round hut. So we'll also put that within our print statement for the round hut. Alright. Inside our print statement for the round hut. Alright, perfect. Now we put that inside the print statement for the round hut. And it says implement floor area for round tower. Your code doesn't run yet and fails with no value passed for radius. Okay, so implement floor area for round tower. Let me see. So we haven't implemented it for round tower, but what error do we get? No value passed for perimeter radius. So, alright, so it wants us to update the round tower accordingly. And round tower, in order for your program to compile, you don't need to implement floor area as it is inherited from round hut. But you need to update the round tower class definition to also have the same radius argument as its parent. Change the constructor of round tower to also take the radius, put the radius after residence and before floors. It is recommended that variables with default values are listed in the end. Remember to pass radius to the parent class constructor. So says remember to pass the radius to the parent constructor. Okay. Alright, so it wants us to inside round tower to add radius for the round hut. So actually we need to add radius inside, pass into the constructor of round tower. So like, let me see, round tower has the floors and the resonance, but now it also needs the radius. And since we have the radius now there, we need to also add the radius here as well. To satisfy the constructor of the parent. And then, so we're gonna, for the round tower, it wants us to add 15.5 for our radius. So we're going to pass in 15.5 up here in our round tower. Alright, to calculate our round tower like that. And also, it's saying, for formatting, you can, um, you know, have these variables on their own lines if that looks better for you guys. So each of these guys on their own line. For readability. And then add a print statement for the floor area. So this print statement will be added for the floor area. Inside the tower. Okay, so, alright, we did that. And you can now run the code. Notice the calculator of the run tower is not correct because it is inherited from round hut and does not take into account the number of floors. Okay, so let's go ahead and see if this one works. I'm gonna go ahead and play it. All right, so this is what it calculated. So this one is wrong because we still need further implementation to account for the floors. In round tower, override floor area so you can give it a different implementation that multiplies the area with the number of floors. Notice how you can define a function in an abstract class dwelling, implement it in a subclass round hut, and then override it again in the subclass of the subclass round tower. It's the best of both worlds. You inherit the functionality you want and can override the functionality you don't want. So now we're actually going to override the floor area method with its custom implementation of the round tower. So inside the round tower, we're adding our new overrided floor area method, which instead of pi times radius, is going to be pi times radius times floors. This code works. So it says this code works, but there is a way to avoid repeating code that is already in the round hut parent class. You can call the floor area function from the parent round hut class, which returns pi times radius, then multiply that result by the number of floors. In round tower, update floor area to use the superclass implementation of floor area. Use the super keyword to call the function that is defined in the parent. So basically, when you return when you actually, let's see. So inside the round tower, we already have pi times radius calculated in our previous um, overwritten method of the parent, which is pi times radius. So instead of repeating that again, we can simply call our super class, and then in our class, our floors will add our floor area will add the extra floors, so we'll multiply by the floors, and so we're using the super dot floor area. Super means our parent, which is the round hut, which the round tower is the child of round hut, and super can be is referring to the round hut. Run your code again, and round tower outputs the correct floor space for multiple floors. Here's the finished code. So the output should be, let's see if we get this output. So this is 1509. The output should be 1509, 314, 2500. Alright, yeah, so that works just fine there. Note for the area values, it would be a nicer user experience to only show a couple of decimal places. This is out of scope for this code lab, but you could print the floor area using this format. Allow a new resident to get a room. So floor area is it, let me see something. So for our floor area printed, so instead of that line, it says that we can go ahead and use this guy instead to display it in a better format, which is two floating point spaces. Alright. So format, can we say this? Like that. Let me try that just really quick. Resolve reference or type. Actually, not that. There. Let me try that. Unexpected expression. Actually, displaying it like this is outside the scope of the lab, so we'll go ahead and, you know, once we get to that in the future, will address that. But for now, let's move on. So, allow a new resident to get a room. Add the ability of the new resident to get a room with a get room function that increases the number of residents by 1. Since this logic is the same for all dwellings, you can implement this function in dwelling, and this makes it available to all subclasses and their children. Neat. Notes. Use if statement that only adds a resident if there is capacity left. Print a message for the outcome. You can use residence plus plus as a shorthand for residence equals residence plus 1 to add to the resonance variable. Many languages use the plus plus notation, which is pretty much why C++ is called, well, one of the reasons why C++ is called C++ is it famously uses this implementation in the C++ language. One, implement the key get get room function in the dwelling class. So we're gonna go ahead and add this new function to our dwelling class. So dwelling class. Our dwelling class is here, and we're adding a new function to it, and it's going to be get room. So if capacity is greater than residence, residence plus plus. Print line, you got a room. Or print line, sorry, at capacity and no rooms left. Tip, in the above code block, you can replace the if condition to use has room function. If has room function defined above compares the resident capacity to the number of residents. Add some print statements to the with statement block for round hut to observe what happens with get room and has room used together. So, all right. So, add some add some print statements to the with. Okay, so we're gonna add the get room after the has room to see what happens there. So after the has room, and after the has room, oh, I'm sorry. Or actually, okay, so the get room handles the print in this case, so we don't have to put it inside the print statement. They wanted us to put the get room after the has room, and so after the has room is the get room. And let's see how that looks. Okay. So square cabin has room false. Sorry, at capacity, no more rooms left. Round hut has room true. You got a room. So since there was space left, you get to have a room in the round hut. Same with the round tower. And that's great. And so C has room. Okay. So C solution for details. This is an example of why inheritance is so powerful. You can call the getRoom function on all the subclasses of dwelling without additional code in those classes. Fit a carpet into a round dwelling. Let's say you need to know what the length of one side of the carpet to get for your round hut or round tower, but the function into round but put the function into round hut to make it available to all round dwellings. First, import square root. So the function from the Kotlin math. So alright, so they want us to import the square root here to our program up here, and then it says implement calculate max carpet length function in the round hut class. The formula to calculate the length of the square carpet that can be fit in a circle is root square root 2 times the square root of 2 times the radius. This is explained in the above diagram. So, okay, that's neat. And then inside, implement the calculate max carpet length function in the round hut class. This formula, okay, so they want this inside the round hut class because the round dwellings are the ones that can have a carpet like this. So we're going to put this inside our round hut. Alright, so we put this inside our round hut, and this will, calculate the max carpet length, and then pass in double value 2.0 to the math function square root, because the return type of the function is double dot integer. The calculate max carpet length method can now be called on round hut and round tower instances. Add print statements to round hut and round tower in the main function. So in the main function, we're going to add this new print statement so that we can see the carpet length. Alright. And, I'm sorry. It's not the square cabin. the round dwellings. And then let us go ahead and play the code. Let's go ahead and play it. Alright. And the carpet length, 21. And the carpet length for round hut, 14. Okay. See the solution code for details. Notice that you added calculate max carpet length to round hut and round tower, and round tower inherits it. However, you cannot call this function on square cabin instance because it doesn't define it or have a superclass that defines it. Congratulations, you have created a complete class hierarchy with properties and functions, learning everything you need to create more useful classes. So this is the complete solution code for the Code Lab. So it's going to be in this lesson here, which is 6. And then, so this is our reference to um, inheritance and classes. And so, 7, to summarize, in this code lab, you learn how to create a class hierarchy that is a tree of classes where children inherit functionality from parent classes. Properties and functions are inherited by subclasses. Create an abstract class where some functionality is left to be implemented by its subclasses. An abstract class can therefore not be instantiated. Create subclasses of an abstract class. Use override keyword to override properties and functions in subclasses. Use the super keyword to reference functions and properties in the parent class. Make a class open so that it can be subclassed. Make a property private so it can only be used inside the class. Use the with construct to make multiple calls on the same object instance. Import functionality from Kotlin.math library. So in this code lab, there was a lot done, and it dove a lot deeper into classes and inheritance. And I encourage you all to continue to study the classes and inheritance, because that's an important concept in Android development and, different object oriented programming languages in general. So, like I was saying in the Learn More, it says inheritance, classes and inheritance, constructors, inheritance, abstract, open, override, private, which we used all those keywords in this code lab, and with for format definition. So so the with statement is pretty nice. It's a pretty nice Kotlin feature which we used today, where we were able to display the information without constantly reusing the object name, like object name dot. But anyway, thank you guys for watching, and that's all we have for today. Continue to stay tuned and stay and subscribe to the channel. And we're gonna be having more tutorials coming out soon for Android development. And the main goal here is to get you to be an Android development pro. And, well, stay coding. Have a great day, guys.